All right, so everybody else wants to do data structures? Or has to do data structures? So we'll go over, I'll start with people and places just to kind of introduce you. Oh, just on time. I will.
I've been sitting in
It-
100
Yeah, yeah.
15 minutes.
It changed recently.
Oh.
Very recently, maybe. I don't know.
Yeah.
I
That's
just
what
sent
I
a
get.
bunch of people
Yeah,
that
that's
way.
what I get for putting things in my calendar in advance.
Uh-huh. So, just in time, this is an important person.
Yeah, sorry. Hey, well, my name is Jacob. I just booked it here, I'm sorry. This is my third time being for this course. I promise you I know anything and everything with this code. It's permanently ingrained in my retinas. I'll be seeing it before I die. It will flash before my eyes. So, any questions, feel free to come over. I have Discord. You can ping me at 2 a.m. and wait, I will respond. And office hours, I'm required to be there. Please come, please attend. Otherwise, I'll be helping students with like intro code. I don't want to look at Python. Don't subject me to Python. My sanity comes office hours. I'm very winded. I just like ran here.
Yeah, it was,
Any questions for me about what I'm doing or? No? Oh, okay. I'm a master's student. I'm doing community-based interactions. My research is going to focus on helping students with disabilities, and that is my bread and butter. I love doing it. So, if you need anything, just let me know.
and so Jacob will be doing all of your programming challenges. So you'll be working with him to demo that and do that part of the course. And he can also help you with anything in this class because he is kind of the expert, I would say, on this. So now I'll tell you who I am. So I'm Zach Hinkle. You can just call me Zach. I'm not a doctor or whatever. If you forget my name, you can just call me something. I'll respond to most things just in my direction. But I'm a PhD student in the CSE department. I work in the STARS lab. So I'm in human-computer interaction, human-robot interaction. That's my area of study. I did my bachelor's degree at Texas A&M University in computer science a long time ago. And there's where I am if you want to visit me in office hours, Butler Hall, room 213. That's my email. That's phone number if you are like, coming to an exam and you get a flat tire and you're panicked, you can, text me or something if it makes you feel better about it. But if you do text about something, let me know who you are because I don't know any of your phone numbers. But I assume you'll just email or Canvas mostly for any kind of contact. So just to tell you a little bit about where I come from, everything is green, but this is a green dot. And that's kind of where I grew up, in this area of Texas. I went to school, College Station, Texas, where Texas A&M is. And now I'm here with you at Mississippi State. To show you a little bit of some of the research that I do, and it's in wonderful green. So these are some of the robots that we work with. It's a wide variety of robots, and we do all kinds of studies. We build robots, we program robots. So if you have any interest in robots or fabricating things, low-level electronics, any of that, the STARS Lab is a great place to do projects with stuff like that. These are just like a couple of them. I'll probably share more of them with you throughout the semester so you can see more of the variety. But these are just kind of some of the favorite projects that we have. So that's what I work on most of the time. And apart from that, teach classes. And so I'm usually my schedule's very flexible. I have some set office hours, but if it doesn't work for you, just email me and we'll find a time that does work. Jacob. All right. So main event for today is our syllabus, which is very long. So just to start with, here's our first correction. So obviously our meeting times, Monday, Wednesdays, Fridays, 1 to 1:50. This is my information that you already got, and followed by Jacob's information that you also have. So a little bit about the course. I think you kind of all probably have a good idea. How many are computer science, computer engineering, electrical, software engineering? Anybody on any of those?
Cyber.
Cyber? Okay, cool. Cyber? Yeah. Cyber, okay, great. Anything else? All right, cool. So, data structures, basically, I mean, we'll talk more about this, about what the class is about, but it's a pretty important fundamental class in computer science and in all of the programs that are kind of related. And so it is a class that's pretty demanding. I wouldn't say that it's incredibly difficult, but it's worth your time. So kind of upfront, you should plan to spend a decent amount of time on this course. You'll do well if you can dedicate the time to it. And everything about it, the way that we're going to do it, I'm going to help you as much as I can. It's not like trying to trick you. It's not trying to make it hard on purpose. We're going to try to step through it in a way that's easy. And it's not like a scary thing. But there is a lot to learn, and it's important kind of as you go on in your career programming things. Our class is on Canvas. Right now there's nothing on there because you don't have any assignments or anything yet. But that's where everything will go, and where you'll turn in things. So in terms of a textbook, you don't need a textbook for this class. If you'd like a reference book, this is one that I recommend, and it's programming abstractions in C++, so we'll be using C++, and it's good for that. A nice thing about it is, there's like a beta version of it that when they were developing it that's still available for free online. Also, you can get the published version online somewhere. So it's a good reference book if you'd like something that will kind of go along with what we're doing, but isn't just the material that's necessarily in the lectures. So in terms of hardware and software required, you'll need access to a computer of some kind that you can compile C++ code on. And it'll be helpful, very helpful if you have a laptop that you can bring with you to do demos with Jacob. If that's a problem or something, let us know and we can figure something out. But that's really the only requirement. And as far as in class, I won't be doing anything that requires you to have your computer in class. So we will do like quizzes and tests on paper. I promise I won't make you write code on paper. So it won't be that bad. Yes, yeah.
Do you have anywhere for us to download the C++, like a link to download the most updated version?
Yeah, so I think, Jacob, do you have Discord resources for that? So,
the
yeah.
Tool Help channel has stuff on both IDEs and compilers, with links to download stuff, and it's like the Microsoft guides.
And where is that at?
Discord and the Tool Help channel. And you can also come to office hours and we can help you get like things set up too.
Okay.
And Friday we'll go through it. So I'll show you on Friday. We'll set up a C++ environment and we'll do kind of a refresher on C++. So that should be pretty good. So that's all you need for this class. And in class you won't need the actual computer. All right, so some learning goals, which is kind of a thing that they make us put on every syllabus, and sometimes it's a little bit like contrived to do it depending on the topic. But here, these actually are pretty dead on and kind of good takeaways for what we're trying to achieve in this class. So we want to be able to understand, we've got like the computer, right? And we've got, let's just say bytes, okay? You can think of yourself as just arranging bytes all day, pretty much, is what you do. And so what we're going to look at in this course is what are the ways that are best, most efficient, established, that people have done, over the many, many years for arranging bytes or data and doing it in a way that makes sense depending on what you're trying to do. And so that's kind of the data structures, is how are we structuring this data. The algorithms are when we look at that data in that structure and we want to do something with it, whether that's, we want to find a certain thing in this big collection of other things, or we want to sort everything. We use some kind of algorithm to do that. And so we'll look at which algorithms make sense for which data structures and kind of learn how to assess those in terms of like computation time and how much space they take, and that kind of trade-off. So that's kind of the main goal of this course. And what's kind of nice is you can take these concepts and you can be as applied as you want with them, or you can be as just basic, like, let's just learn what a linked list is. We don't care what the data necessarily is. We're just building this structure to put arbitrary data in. We'll try to relate it to things like real applications, because obviously this is kind of the foundation of a lot of real things that happen. All right, so grading, and kind of the vision of what your grade will be based on. So we'll have a refresher challenge, which I will post either tomorrow or Friday, and this will be your first challenge, and it will be essentially you setting up a C++, compiler and an environment where you can write code and run it. And we'll have like a few things for you to do, and they're simple things, like take some input, print something out, that kind of stuff. It's just to make sure you're up and running before we take off and start doing other things. So that will be something that we take care of very early on. So throughout the semester, we'll have these programming challenges. There are 4 of them. And the way that this works is you will get the challenge, and it will ask you to do something like, for example, implement a linked list. Okay? And in class, we will go over linked list, and we will actually have all of the code you need to implement a linked list in class. Okay? And so your job will be to put that together into software that works. And then there will be a second thing. And the second thing is something that you will be demonstrating to Jacob, most likely, or a TA for the course. And essentially to show them that you've got a grasp on what the code's doing. And it's very well stated in the assignment exactly what you need to do. Like you need to take this singly linked list and make it doubly linked. And so you'll have plenty of time to study that, to make that solution, to understand that code. But what you'll do is whenever the assignment is due, you'll go in with just that base code that doesn't have that second part, and then you'll add that second part. And you'll have the opportunity to do that. Like if you go in and you can't get it or something's not working for you, you can reschedule and do that again. If it's kind of like one of those things where it's a little bit like nerve-wracking to go sit there and demo something, don't worry. We're kind of on your side, trying to help you through as much as we can to just show that you've got an understanding of the code and to help you get an understanding if it's not clear in class or something like that. And if you guys have questions at any time, just let me know. Happy to answer them as we go. Okay, so that's programming challenges. There will be 4 of them throughout the semester. And that's 30% of the grade. 10% of the grade will be quizzes. These will be in-class quizzes, and there will be about 1 per week. I usually will not do one whenever we have like an exam that week or there are just other things going on. With these quizzes, there's usually between 8 and 10 of them. I drop the 2 lowest always, just automatically. And I'll kind of give you a hint that like Wednesdays are a good day for quizzes because Monday's kind of the beginning of the week, and Friday's more likely, if you've got something and you have to be out of class that day. So Wednesdays are probably the quiz day. Quizzes are, again, meant to be helpful. They're meant to kind of keep us on top of things, don't get behind too much. So it'll just be about 10 minutes at the beginning of class. It'll be on paper. We'll do it. We'll go over it. They'll turn it in. If you're, working hard in the class and you're getting things and you're doing well, quizzes will not hurt you. I can promise you that. if you are going to be absent, and we'll go over this kind of for everything, but if you know you're going to be absent, like, you know, you've got a conference to go to or somebody's wedding or whatever, if you let me know just in advance as much as you can, that helps, and we can schedule a different time for you to make up like a quiz. If you are out for like an excused absence, you know, like you're sick or something, same thing. Let me know as soon as you can. It doesn't have to be before, obviously, because you wouldn't know that necessarily. But the sooner you can get in touch with me, we can make sure that, you know, you don't get too far behind or anything. And we don't want you to like lose points or anything like that. It's not meant to hurt your grade. It's meant to help you kind of stay on top of things. Then the main component of your grade is exams. So there are 3 exams, and they're just evenly spaced throughout the semester. Each one is its own set of topics, so they're not comprehensive necessarily. There might be some carryover from the things you learned early on, but it's 3 exams, and that makes up 55% of your grade. However, if you have a bad exam and you kind of want to fix that, there's an optional comprehensive final. And it's not an exam that's any harder than the others, it's just comprehensive. It's a chance for you to kind of make up time. Like, say you got behind in the semester for something, but you managed to like get back on track and you understand this stuff, and there's really no reason that you should have, you know, a horrible grade in the class because you know the things now. And if you want to take the comprehensive final, and if that grade is higher than one of the exam grades, we'll replace the exam grade with that grade. Yes?
Is there a process to like studying for the exam? Do you have like practice tests or anything
Yeah.
like that?
So when we do an exam, we will usually have at least one full class of review before the exam, and I'll kind of make you a handout summary sheet for the exams, and we'll talk about it as we get closer. For exams, like, I'm not interested in you getting C++ syntax correctly on a written exam. If you can convey to me that this is like this variable and this pointer and whatever, and you're doing this with it, that's kind of how I look at things. We're more interested in you understanding the concepts than like getting perfect written code on a written exam. Now, obviously, when you write code, you know, on the computer, it won't compile if it's not right. So it does need to be right there. But in terms of exams, yeah, we'll do reviews for each one, and we'll gauge as we go. I'll try to get your feedback to see where people are not getting something or what we might need to look at in more depth, so that we're all kind of in sync there about the exams and what will be on them. So programming challenges, which we talked about a little bit. This is more detail on the programming challenges, and it's a little bit of a kind of a detailed scheme here. But so essentially, we talked about that base solution that you implement. The main thing that you do is you demo the base solution, and you make that change with your TA, and they check off that you've done that. And there is a time window for that. And so you'll schedule a time to do that with the TA. And the way that it works in terms of being late is that once that last day for full credit is over, there's kind of this 5-weekday countdown where each day, like 10 of the possible points go away until you get to, I think, 40. I'll show you an example in just a second. But and then at that point, the only there are 10 points for turning in everything, which you can do that up until the last day of class. So the important thing is to, on time with each of these challenges, go and get it checked off with the TA, do the demo, and be successful with that. Then you have until the end of classes to submit your final code and your documentation for that. And you can submit that even if you don't get it checked off. If you do it after that, you can get those 10 points still up until the last day of class. And so just to give you an example, because it is a little bit complicated. So this is kind of the way it will go. Essentially, we'll assign a challenge And then you'll have, usually it's about a week. I will try to release them, to give you as much time as I can. We do have to stay in sync with the other sections, so I'm a little bit constrained on what I can do there because we want to make sure everybody's on the same schedule with these. So, but you'll always have at least a week from when it's released until the kind of the main, I'm just calling it demo day. I don't know, Jacob, what you like to call it, but
I have words.
yeah.
Yeah.
So you'll go for that, and if you do that on the, by that deadline, you can get the full points. And then you can see, as we go on, where the kind of points decrease and what's possible there. So we don't, like weekends don't count if this kind of overlaps with the weekend or anything, those don't count as late days. And if it's like a university holiday or something, that doesn't count. But I don't think any will be falling on that based on the schedule we have.
May I add on?
Yeah.
Demo signups will go live at 8 a.m. on the Friday, whenever it's the Friday of the week that it's released for the class. So it's first come, first serve. It will all be done, well, I will be there for 8 hours that day, and I have 250 students. If you come by at 5 o'clock and I'm very tired, don't be surprised. So, very long day.
Did you tell us like you have SI times where you like reteach the?
William does, and he's in the Discord, and is he in the Canvas page as well?
I don't think he's in there. I'll pull that info in to Canvas. Yeah, our Canvas is just a syllabus right now with the wrong room on it. So
SI's great though, and I would highly recommend it.
Is he gonna sit in the class with us?
I believe he's sitting in Knight's section 1 for his information.
But it'll be the same material.
Yeah, and if you request anything, he is more than likely willing to include it as well.
yeah. And in case you guys didn't know, there are several other sections of this course being taught, and so I think there's 2 other instructors. So we kind of all try to communicate with each other and stay on the same path. So all of like your TAs and your SI leaders, they'll know kind of where we are as a group. And yeah, I will. The Discord is great, and you should join that. If you don't like Discord or something, it's not required, and I will move the info for like SI and everything into Canvas so that it's in our official communications. And that is a good point. Like if you do need to tell me that like you're going to be out for an exam or whatever, please be sure to send it either like through Canvas or to my MS State email, just so we can be sure that it comes to me and there's no question about like where the message went and anything like that. So. Okay, so let's talk about getting ChatGPT to do your work for you. Does anybody use like Copilot or anything? Anybody like ask ChatGPT to write code yet? Yeah. What are your experiences like? Good? Good? Well, okay. Yeah, I've been using it. I tried to like use it all summer. And I kind of like mixed reviews. So I'm using Copilot like in VS Code. And for the most part, it's great. It's really impressive how quickly it can write your software for you. Sometimes it's not great though. And I find like the tireder you are, the more willing you are to just be like, okay, that looks good. And then it does something wonderful for you that you don't notice. And it's quite a pain. But you should all try these tools. Just in general, because kind of as people in this field, this is an important part of it. And it is possible that these tools will have a much bigger role in the near future than they have right now. Right now, we're all kind of unsure about just where exactly they fit with things. And no one is more unsure than the academic world, where we're trying to make sure that you know how to write code and do these things on your own. So, when you do programming challenges, kind of is the first thing I want to talk about. All your code that you write needs to be written by you. Do not ask any of the large language models to write like a linked list for you. Don't ask any person to write it for you. We're just going to treat kind of any large language model or anything like that, just like we would a textbook or a person who's very informed on the topic, right? So in terms of like academic dishonesty and stuff, it's the same. We wouldn't let you have some random person do your work for you. We wouldn't let you copy and paste out of someone else's work and turn that in. So that's where we are on that. Now this can get a little trickier. So when you do a demo with your code, and you'll be there writing code, if you're using something like VS Code or an IDE that has the large language model generation built into it, so like you start typing code and it starts suggesting what the next bit of code could be, you're going to have to turn that off while you do the demo. And I think that should be pretty obvious. So I would encourage you, probably when you work on stuff in this class, just keep that turned off if it's in your development environment. Because we really want you to learn these data structures. And it's honestly, it's not helpful to have the large language model generate it because it will do it instantly. These are established things. There are a ton of them out there. They're standardized, you know, and it's just as easy to like search and find one and use it. So just in general, try to kind of isolate yourself from all of that when you're working on your assignments and doing your coding. It will help you. So the other part of that is, you know, I don't expect that you shouldn't just sit there and like struggle. Like if you don't know how to implement something, obviously, like, you know, look it up or you know, open a textbook if that's what you want to do. If you do that, you should still process that information and generate your own solution based on that. But just to be sure, if you do that, the best thing you can do to kind of just make sure that you protect yourself is just put a citation in your comments for that. You can't cite the large language models. We can't do that because they can generate novel code, you know, for everybody. But if it's something like a book, a website, whatever, just, you know, put a comment, put a URL, like, you know, I based this off of what I read here. And that'll help us a lot if there's ever a question about something. That citation is, you know, kind of your protection there because you've acknowledged, you know, what source you used, and we can look at it and see that.
So if we watch like a YouTube video?
Yeah, just put the video URL in there. And you can just, you know, put a little comment like, you know, what you got from it, or, you know, like I used this to design the way I did whatever. And that's fine. Again, as long as you don't copy that work verbatim, just like you would writing a paper or anything else. And if you ever have a question on this, just let me know. I'll look at it. We can make sure that it's okay. But that's kind of the most important part in terms of us writing code and dealing with the large language models or any resource really. So and we'll see later in the syllabus that kind of our stance on this, like we have to have university policies now about generative AI. So our class is a no generative AI class. That just means for your work. You can't use it on the assignments, the exams directly. If you want to use it to talk to and learn things on, you know, about whatever, that's fine. But you just can't use it to do your work for you, which isn't that well of an idea. Okay, so programming languages. We're going to use C++. Does everyone love C++?
I use it.
You use it? Okay. Is it anybody's favorite language? Okay, yeah. All right, everyone say your favorite language on 3. You ready? 1, 2, 3. JavaScript. Okay. You guys program, right? Has anybody not programmed anything before? I think you have to have done it to get into the class,
Yeah,
right?
we have to have programming 1 and 2.
Okay. So I'm going to go through C++, and as we do things in here, I'm going to kind of assume that you don't know C++, even though you probably do. Has everyone been exposed to C++ in prior courses? I think so, right? Yeah? Okay. So if Does C++ make anybody nervous, I guess? Yeah. Okay. Yeah, me too. I don't use C++ a lot day to day, I will tell you that. When I do use it, I use it for very like low-level microcontroller stuff. And so I don't, with that, it's more C-ish code. It's not like this object-oriented stuff, which we're going to do some of. But our goal is going to be to not let C++ get in our way. If it's something that is difficult or bothersome to you, we will do everything we can to limit our investment in the language itself. So I will not be asking you to learn like the C++ like most recent standard and like all the features and every little bell and whistle. I should tell you, C++ is a great language, and it is used everywhere on everything. So it is valuable to know, whether you like it or not. I went to Texas A&M. The guy who invented C++, Strustrup, he teaches there. So I got to experience many lectures from him about the language itself. And even he would, kind of talk a lot about the standard as it evolved, and it's a huge, complex thing, and it's really interesting. It's a language that powers a lot of stuff, so it's a good one. It doesn't have to be your favorite, and I guess what I'm saying is don't worry about it if you're a little bit nervous about C++ being part of this. If you find that the language continues to like get in your way, like you know what you want to program, but you're fighting with the language and the compiler, let one of us know, and maybe we can, or just anybody, really, like somebody else who's in the class or something, talk through it. A lot of times that helps kind of to solve if there's just like some concept or something that is like really hanging you up. And it's so much better once that's done. You don't want to fight the language ever because it'll sink like most of your effort, and you won't have the time to do the thing that we're doing. Okay, so tentative topic schedule. This is pretty much how we're going to do things. It may shift around a little bit. So we'll start this week just doing an intro, getting kind of back in gear with our development environment, C++ running, and talking about the basic C++ stuff tomorrow or Friday. And then next week we'll move into actually starting on some data structures, and we'll start with linked list. And then we'll just continue going through this schedule. And we've got a bit of flexibility in the schedule, actually, so we'll kind of try to adjust this in the best way possible. If you have anything, I've tried to put these exams where I think most people won't be like away or something. But if that is the case, like if you have something that you've committed to already, it's okay. If you just let me know, I can set up a different time for you to do the exam, and that's fine with me. Same thing if you're coming to an exam and something goes horribly wrong, like you get in a car accident or you're just sick or whatever, let me know as soon as you can. You can make up the exam. Don't abuse that system. Nobody does really, honestly. But don't worry too much if one of those outlying events happens to you. We're here to help you to make sure that, we don't want like life circumstances just to like sink your grade in here for no reason. Okay, so some policies real quick. Attendance. You should attend class. If you're not going to attend class, let me know. We're not using the ID scanners. So kind of honor system there. You should attend class. If you don't attend class, you'll get behind. It'll be awful. Makeup policy, I kind of just went over that. Essentially, certainly anything that's under like university excused absence, that's no problem at all. Just let me know about that. And also anything that's planned in advance, let me know, that's no problem. And then anything that's not under that policy but is really just like you had no way of knowing, that's fine. We'll take care of it. And that's for like quizzes too. Same thing if you miss a quiz. The AI policy, there's that official policy, don't use a generative AI. Communication policy, everything through Canvas or Mississippi State email. But do use the resources like Discord and anything else that you have to talk with others in the class. There are a bunch of standardized policies that apply to every class here, and you can read those there. Kind of the main one that may affect you, if you have like an accommodation or something for like extra time on an exam or whatever, if you'll get in touch with me at some point before that, let me know, we'll get that set up, and that's no problem at all. Honor code, we all know that, and that is actually in the standard thing too, so. All right, there's a revision log. I think today I made the last change on this with this room number, but we'll see. Okay, syllabus is done. Are there any questions? It's a wide room, usually in a room that's narrow. So. Okay. If I don't see you, like raise your hand, just shout at me, it's fine. Okay, so briefly, I'll just talk about what we're going to focus on. We've got a few minutes left. Okay, so this is kind of on that main schedule and rendered in wonderful green again. These are some of the main data structures that we'll cover, and in what is supposed to be a bluish color here. These are more things that are done on these data structures, so algorithms, if we want to kind of frame it that way. So we'll spend a lot of time looking at these structures themselves, which are, again, just ways to arrange data. And I'm sure, like, most of you have probably seen an array, or a vector, or a list, or a dictionary, or whatever your favorite language, or the language that you've learned, you call it. Collections of data, right? And that's kind of like the simplest one. We're going to look at different structures for that, and you may know all of these, you may have heard some of them or none of them, and that's fine. Hopefully, it will still be worth your time to kind of go over them the way that we do in this class. And we'll also do time and space complexity, and it's kind of like the easy version of that. So you will take another class, most likely, depending on your degree plan later, that will do that in more depth. But we'll do kind of the basic version, kind of the good to know version about, you know, is this thing going to take 300 years to run or not, which sometimes happens. So, goals. These are kind of related to those learning outcomes, but we want to understand what these data structures are. And again, these are things that have been around for a long time, and they've stuck around because they're good. And one reason that that's important, I think, is just to be able to talk to people in our field, right? Everybody who's in this field who goes through a program to kind of become either get a degree in it or certified in it or whatever it is, can speak this language. They can talk to you and say, hey, you know, this is using a linked list, this is a queue, this is a heap, this is whatever. You need to know those things, kind of what they mean, what the implications are for that. So these are very good basic skills to have for this field. They're essential. When you do job interviews, if you do them at big tech companies, these will be the kind of interview questions that get asked. There will be a lot of things related to data structures and runtime analysis and that kind of thing. This will be the stuff that you will be restudying as a senior when you're doing those interviews. So it's a good thing to kind of invest in as soon as you can to learn it. And it's enjoyable, I will tell you that. It's generally, and most people do enjoy it, again, as long as you're not like fighting the language or dealing with something else. It is very interesting, and it's a big part of the field of computer science. But we want to understand how these things work, kind of what's going on under the hood. So it should be no surprise to you that out in the world, you will never have to write a linked list because it's already been written. You will just import linked list and use it. So, you know, as you go later in your career, all you really need to remember is how to use a linked list, probably. But for now, it is great to know how they work and just have an idea of that, because you need to know when to use it. Like, when should I use this versus that, and things like that. So we want to be able to kind of understand these things, and you can think of them as like tools for solving, you know, arbitrary engineering tasks or whatever problem you're presented with. And these are potential tools that you can use to solve those problems. And when we think about the analysis of how algorithms work on these structures of data, that is more like, we've got all these tools, which one is the best, most efficient to use to build this thing? And so those kind of go hand in hand, and there are trade-offs, and we'll spend time talking about that. Okay, so that sums up everything I want to cover today. At the end of every lecture, I like to put up action items, just so we all kind of stay on track about what, things that are due next, and then what we're going to do in the next lecture. So you don't have anything due yet. I do recommend, if you get some free time, make sure you've got C++, running on your computer, got the compiler going, you can compile code. That'll help you with the first programming challenge. But then on Friday, we will review C++ and hopefully master the language in 50 minutes. But that's all I've got, so I will see you guys on Friday.